not that short. Okay, I'm Gonzalo Tancredi from Uruguay, and in fact, I will announce that my talk and the next one by Duncan Steele will be the only two talks from southern hemispheres, people coming from the southern hemisphere. And I think maybe one can raise the hands of those coming from the southern hemisphere, but we are just 2, 3, maybe. So we are very few ones. Well, in addition, I'm the actual president of the Division F of the IAU, the Division of Planetary System Astrobiology. And in that sense, I would like to say that our division, and I suppose also Division A, where the president is here, it's very interested in this field of planetary defense. So my presentation is a collaboration with two undergraduate students, Ismael Acosta and Natalia Beltrami. Those are there. And well, what we have done is to analyze the database of meteorite falls and fireballs. In particular, when meteorite fall, it's considered when part of the event leading to the delivery of a meteorite to the Earth has been witnessed, and all the others are called meteorite finds. In the Meteorological Society database, there are on the order of 60,000 meteorite names, but only 1,100, a little more than 1,100 falls. And in particular, we can consider also what is called what we call damaging falls, that a fall that directly impact human beings or their belongings. For example, a house, a car, but not the pavement. There are only 105 reports of damaging falls from the 18th century until present. And we make a list of them. There are a lot of nice and funny anecdotes about them, but I will not go into details. What we have made is, for example, an analysis of the evolution of number of reported falls. And you can see here that the number has increased a little bit, but has been pretty stable in the last century, or a little bit more than a century. And there is on the order of, at present, for example, 95 reports in the last 12 years that corresponds to the order of 8 reports per year of meteorite falls. And damaging falls has also increased a little bit, but at present it's the order of 2.3, sorry. So it's on the order of 1/4 of the number of damaging of the number of falls that has been reported as damaging ones. Maybe one cause of this increase in the mid-19th century and at present could be the increase of the telecommunications. From these estimates, we can compute a figure of how many falls are per year. If you take into account the number of the amount of land that is on the Earth, the amount of urban land. The urban land is on the order of 0.13 of the total area of the Earth, or 0.24 of the area covered by land, and also consider that most of the population in the world is in the urban areas. So the urban land corresponds to a large fraction of the area where there are witnesses of a fall. So we can use this number of falls in order to estimate the number of total falls per year on the Earth. The number of falls in urban land divided by the fraction of urban land gives the total number of falls per year. So we get a figure of the order of 6,100 meteorite falls per year over the entire Earth, or 1,800 over the land. This estimate is a little bit higher than a previous estimate that was done by Halliday in 1984, based on a network of all-sky cameras. But that estimate by Halliday, it was based on photographic observations and a lot of assumptions about the meteor physics law when they are crossing the atmosphere. So I think our estimate is better in the sense that we are using far less assumption. And also, the ratio between the fraction of damaging fall could be a proxy for the fraction of the urban land covered by the buildings. It's something that you cannot find in the literature, and so we can estimate that the area covered by the buildings is on the order of 1/4 of the urban land. Another information that one could extract from this database is to answer the question whether there are meteorite streams. All of you knows about meteor showers produced by particles released by a comet, and if you make a plot of the rate of meteor falling onto the Earth, of meteor falling onto the atmosphere, you can see that there are clear peaks in this rate corresponding to the meteor showers. For example, the Perseids, the Orionis, the Geminids, and so on. But what about meteor streams? Meteor streams is not meteor showers. Meteor stream is a group of meteorites that are sharing a similar orbit. Also, we have to take into account that meteor falls are produced by at least a few tons meteorite, larger than 1 meter. And a few tons meteorites are not affected by small particles non-gravitational force, like the forces that are affecting the dust coming from comets. For example, radiation pressure or Poynting-Robinson effects. So if a meteor stream exists, it should be very compact. So what we have done is to analyze, and this is relevant because if a meteor stream exists, it could be that a much bigger object could exist in this stream. So what we have done is to make a similar plot as the one for meteor showers, and well, we are working with small numbers. There is only 1,032 falls with confirmed dates, and we don't see any clear peak. We can make a more detailed study because we can suppose that this is a Poisson process that has a very precise or very well-known distribution. And if you compute the distribution, the number of falls per degree, and you can fit a Poisson distribution very, very good. So there is no clear evidence of a large tail, or there is no clear evidence of a large number of meteor falls in a particular date. So the meteor falls occur randomly throughout the year. There is some caveat about this because the report of they have one-day resolution. In most of the cases, we don't have exactly the time, and the time it's different among different places in the world. So one could, for example, compute the same with a running mean, and even in that case, we don't see any peaks in the tail. There are some peaks here in the distribution, but not much higher than the background. So the conclusions is that there is on the order of 6,100 meteor falls per year over the entire Earth, 1,800 over the land. Also, one could analyze the meteor showers with asteroidal orbits, and there seems to be 40 showers. There is no clear indication of an excess in the distribution of falling meteorites and fireball with date of or solar longitude. So the heavily populated meteor stream seems to not exist. Therefore, the conclusion and the answer from my initial question is there is no particular date of the year to be outdoors with a helmet. There is no preferred date for a doomsday, so it's not necessary to wear like that.
Oh, thank you. Well, you ran a little more than 4 minutes, but you actually are quite well under time. So we have questions. Anybody have a question?
Yeah, I'll ask you a question about your assumption about the urban density. So coming from a place that is rather rural, we have certainly houses and agriculture and stuff like that that would probably fall inside your 1 kilometer by 1 kilometer square. But how do you account for the fact that, you know, people can see further than your square? And so, you know, when you do your devising to find a number of squares, you know, it's when a person is inside one of your 1 kilometer boxes, that makes up, you know, the fraction of urban area that you call it, they can still see miles to either side or kilometers to either side to the horizon and still see the falls and therefore go and locate it. Have you accounted for that in that 6,000?
Well, we are not talking about seeing the fireball. We are talking about picking the meteorite on the ground.
Right, but if they see the fireball, then they could go, and the more rural areas, well, the easier it is to actually find the meteorite.
I mean, I think one of the cause of this increase in the last years is that there is, for example, a lot of all-sky cameras that could make a precise estimate. But it's, I mean, just from visual observation, it's not possible to make a precise estimate of where the meteorite could fall.
Sure.
So
Okay.
I don't think it's necessary. I mean, and I know that there are some places on the Earth that is heavily populated, but most of the places on the Earth are very low populated.
Okay.